topic is Regula Falsi method. This method, the another name of this method is false position method also. Okay. So in the previous class, we have already studied bisection method, correct? So in that bisection method, what we have done actually, we have considered one point CA, let us see, which is actually A0 plus B0 by 2. Okay. Or we can say AN plus BN by 2. Okay. So AN plus BN by 2. Okay. What is this C? C is the middle point of this interval AN and BN. Fine. And what is the graphical interpretation? And graphical interpretation was like that. Say if any curve, okay, if we have to find the root of this curve, okay, then you have to consider one interval, at least one root should lie between that interval endpoint of that interval AN and BN. And then you are making a half of this one. That means you are considering middle of these 2 points, okay, as a C. Let us consider like that C. Okay. So this is f of B, f of Bn, and this one is f of An. Okay. Now, what is the graphical representation? What is the computational scheme, and how to find the computational scheme for this method, Regula Falsi method? Okay. So first, actually, before we start this one, I have some query. Okay. Just say this is straight line. Okay. This is okay. Both all are straight line. Okay. Now A, B, C, D, and this is set P. Okay. Just what is this graph or this diagram? Sorry. What is this diagram? Okay. Can you find any relation between these two triangles? Anyone? Is there any relation? What is your role? What is that? Okay, just wait. Okay. Anybody else? Any other? Anybody else? Can you answer? Is there any relation between these two triangles? I have already marked it. Okay. Is there any relation? Already that rule number 42 already informed that these two are similar type of triangle. Okay, now. So based on that, you should answer. Okay, you have already studied trigonometry, correct? I think in during your 12th 10th standard, correct? So yeah, rule number 42. No one is ready to answer. You can answer now. AP by PB. Okay. So this is the AD. You are telling AD by CD. AD by CD. CB. Okay. CB. Fine. This one. Okay. This is the actually the relation between these two symmetric triangles. Okay. So fine. So I will erase this one. Anybody having any doubt? C, not CD, it is CB. Okay. I have written wrongly. CB. Fine. Yeah, your answer is correct and your concept is also correct. Now I have erased that one. Okay. So using that concept, just few minutes back we have discussed. Okay, now based on that, okay, we can find what is the application of that one. You just see, okay, y equals to f of x. Now we have to find the root of this curve, say, okay, and you know the root is this one. Okay, so similar fact that you have to consider one interval an comma bn. Okay, similar to the bisection method, that you have to find an comma bn, one interval, such that at least one real root exists. correct. Here it is positive root we are finding right hand side, negative root also same procedure, no problem. Okay, so what is the condition that at least one root lies between an and bn? Okay,
f of an
into f of bn is less than 0, correct? Now it should be negative, correct? So now let us consider that this is an and this one is bn. Okay, bn. What we did earlier, actually in the earlier bisection method, we have considered middle point, correct, as a new point or new entry, and then we have checked an and c and bn. Okay, where the root actually lies, correct? Now then we are discarding one. Okay, the two same length that section are there, you have to erase, you have to omit one. Okay, now in this method, okay, regular falsi method, what is the graphical concept? It will make you clear. Okay, now f of a into f of b, that one you have to check. So that means at least one real root exists, correct? So now the same procedure, if we consider here f of a an and this one say f of bn. Fine. So now this time we should not consider as the middle one. Okay, you have to draw a straight line between an comma f of an and bn comma f of bn. So you already studied that one, how to find the straight line. Okay, equation of straight line. Okay, fine. That equation, it may not be correct straight line, but you have to consider that, yeah, my drawing is correct. Okay, exactly. Okay, for understanding purpose only now, let us consider this one. Okay, this is the straight line. Fine. So the green one is the straight line, let us consider. Okay, so earlier you have considered this is the middle point as a point for the case of bisection method. Now in this case we have to consider this point, crossing point of straight line joining between the point an comma f of n, that means you can say p and q, correct? Joining the point sorry joining the point a, p and q, the straight line, this straight line, okay, crosses the x-axis at the point, say something a, b, let us see. Okay, so now this is the new point c instead of the middle point. Okay, so now you have two triangle, just see APC and CQB. Fine. So now this is the new point, say C. Now earlier it was AN, correct, and BN, sorry, AN and BN. Now you have another point C, arbitrary point C. So now you have to check the root lies between AN or AN comma C or C comma BN. Then that interval will be the next interval for this computational technique. Fine. So now from this graph you can answer what will be the correct that interval. Okay, for the next step, first one or second one, CNBN. Okay, so this part you can see what is the concept. The mathematical concept is, I am drawing again. Okay, the mathematical concept is, you can see this one C comma f of C, correct, and this one remaining same Bn comma f of Bn. What is the next step? So let us consider this point is something D. Okay. Okay. Or if you yeah, correct. Now what you have to do next? Join Q and D. Fine. And if you join Q and D, okay, again that straight line, okay, that straight line will touch or will cross the x-axis. Okay, this crossing may be right hand side also. Okay, it is for understanding purpose only. I am drawing all this one. Okay, it may cross this side also, no problem. Okay. Okay, so now D and Q, if you join, let us consider this is the point, and this point if you consider say R. Okay, so the new position, the new point is R. Okay, so earlier C comma, earlier it was C comma Bn, now one point is R. Okay, the same procedure you have to check. C comma R is the correct interval. That means the one root lies between C comma R or R comma Bn. Again, this graph actually, according to the drawing, this the root lies between R and B. Correct now? R and B. So we can say this one is B also, no problem. So R and B. Fine. If you proceed in that way, okay now, you will reach this point, okay, very fastly compared to the bisection method. I repeat, you will reach very fastly to the point this one. What is the answer? What is the solution? At what point the solution exists? That means root exists. That is S. Correct now? S is the root. So x equals to S is the root of this one. You have to reach that point. Okay. Now you have not asked why this point is faster. We will discuss that one also. Okay. So just statement right now, you can remember this statement. This the convergence of this method is better compared to the earlier one. Okay, that means bisection method. We will discuss that one. Okay, mathematically. So now these are fine. I will go back to the first drawing. Okay, so if you continue this process, you will reach up to that S. Okay, that means if you at a time, one time, you can find that if you join like PQ or DQ, okay, in similar way, if you join that 2 point, that straight line will cross S exactly through S. Okay, then you can stop. There you can stop, and that is your solution. Okay, that means then only you can reach the solution of the that equation. So what is the equation? F of x equals to 0. We are going to solve, and f of x is the curve. Okay, that is actually initially I have drawn. Okay, now mathematical computation. What is the mathematical? How you can derive that one? Okay, so I will go to the next slide. Okay, next page. Okay, what is how you can find the mathematical formula for this method? Okay, I will draw it. Okay, so let us consider. Okay, this is the curve. Okay, and now you have to find the initial approximation. Correct? An, say it is A, that is An or A naught. Okay, general form, and say B is Bn, and it is say B. Fine. So now, okay, this is the point is An comma f of An, and this one is, okay, this one is, okay, this one is, what is that? Vn comma f of Bn. So now I will write this one is P and Q. Let us see, this is P and this is Q. Now if you draw the straight line, okay, if you draw a straight line between these 2 points, between these 2 points, you can check like that. Okay, so this point, the crossing of x-axis, say it is C. Okay, and this point is say R. Okay, so P, Q, A, C, R, B, all we have right now. Okay, just see. The initially actually we have considered this point and this point. Okay, the one root lies between this one. Okay, so if you consider A as a initial approximation, and now the second solution is C, you can check that this amount, actually this amount, this is the increasing towards the solution. So that is called Hn. Okay, so that is called Hn. Okay, I will tell you the concept. What is that? Say initial solution you have considered Xn. Now you have to update it and say the next iteration Xn plus 1, the solution is Xn plus H. This is the H, maybe negative or positive. Okay, and that one we have to find. Okay, this will give you the next solution. Now what is this H? Okay, so for that one we have to consider that concept. Okay, and just few minutes back we have already discussed. Okay, AC divided by, okay, AQ equals to, somebody should say what is the answer? AC by AQ equals to BC by or CB by something. Correct. CB by B. Correct. This one. Okay. So what is the comparison? This one and this one, this one and this one. Okay. So that is the comparison. Now you just check. Initially we was there at A and now at C. So ultimately, what is the AC we have to find? What is the AC? The AC equals to CB BP AQ. Any doubt? Okay. So you just see, we will write this one just AQ by PB or BP into CB. Okay. What is AQ?
F of an, sir.
F of an, fine. F of an. Okay. So this is F of an divided by, what is BP? F of Bn. What is CB? Can we write this one? AB minus CB or BC? Sorry. AB minus CB, AB minus AC, correct? AB minus AC. Okay. What is what is AB?
Bn minus An, sir.
Bn minus An. Fine. Okay. Bn minus An. But fine. What we have to find actually? We have to find AC. Now both sides AC are there. Here is also AC. Here is AC. Okay. So we have to do some algebraic calculation. Correct. Small algebraic calculation. I will write in that way. Okay. AC equals to AC plus. Okay. F of An divided by F of Bn into AC equals to F of An divided by F of Bn into AB. Correct. What is AB? Just few minutes back you have answered An minus Bn. Correct now? So we can write what is the AC then. Therefore, you can see the answer. Correct now? What is AC? Now 1 plus this one. Correct now? AC common, 1 plus this one. Okay. And this is An minus Bn minus N. Correct now? Bn minus N. then only you can bn, that is bn minus an, this is you have to find. So from origin to this one is bn, and you have to subtract from origin to a, then only ab you will find. Okay, you can find. So what is the ac? Can you answer? Simplify it. Okay, I will erase this part, then I can easily simplify this part. Okay now. AC. So fine. Now this is AC, correct now. So you just check AC into f of an plus f of bn, okay, divided by f of bn, okay, that one equals to right hand side f of an into bn minus an divided by f of bn. Okay, so now since all are actually length, distance, so length should not be negative. Okay, but f of an, it will give you the negative answer. Hence left that it is down, I mean, y axis, this is positive, but this is negative. Okay, so similar case for other case also, maybe f of a is negative, that is also possible. Okay now, so that cases, for that purpose, what we will write? Okay, now this is the, if you simplify from this expression, okay, we will get AC is like that. AC equals to, okay, f of a n into bn minus an, we will take modulus all, okay, divided by f of an plus, just wait, f of bn, already I have taken. To maintain the generality, that means sign, okay, we will take all our modulus. So these are the modulus form, okay, positive value of the distances. It's fine. So AC, that means initially x naught or an is the answer. Now the answer is an plus h. So this is the h, and that is AC. Therefore this is, I will not write again. Okay, therefore here instead of AC we can write h equals to this. Fine. Anybody having any doubt? So this is the mathematical form. That means you have every step you have to find h, that h. Okay, this one. Okay, this h you have to find for each step using this formula. Okay, so this is the improvement of the solution. We can say this is the improvement of the solution, this one, this expression. Okay, so xn plus 1. So if we say that earlier solution is xn, then the new solution xn plus 1 is xn plus 1 equals to xn plus h. Okay, where this one, where h equals to this one. Okay, so now I will write the computational steps for this irregular falsi method. Okay, if you have any doubt, you can ask me now itself, no problem. This one is very simple. Okay, geometric concept, sorry, trigonometric concept you have studied, that one only we have used, and finally we will get the h. So now this one, okay, first h like that. Similarly, if you proceed for the next iteration, you will get another h using the same formula. Okay, h. So no need to find every time the formula. So now computational steps, these are the concept. Now the computational step. What is the computational step for this one? Okay, so what we have to do, we have to find one first interval. So step 1, find an interval a0 comma b0 such that f of a0 into f of b0 is less than 0. You have already studied that one. Okay, for the bisection method, you have find that interval, initial interval, correct. Now earlier you have written very few entries, now here entries are more. Okay, right, that means that table. Okay, now computational, in a computational table, what you have to write? You have to write n. What is the meaning of n? Number of iteration. Okay, now an, vn, you know already that lower bound, upper bound, correct? F of n, these are hyphen, okay, na, not minus. Okay, in the table you need all these entries: 1, 2, 3, 4, 5, 6, 7, 8. Okay, these 8 entries are required for your new computational scheme, regular Falsi method. Okay, na? So you just see n, an, bn, f of n, f of bn, h of n, x of n plus 1, and f of n, x of n plus 1. So last one actually we need actually for sign to determine the sign. That means it is positive or negative. Last one, this one. But for that purpose also you have to evaluate it. You have to evaluate that one. Okay, na? So for each step you have to find all this one. We have to frame or we have to construct a table, and then in that table we need all this information. Okay, now like earlier table, how to replace an value and bn value, that one actually in the step 3. So write an plus, that means this one is plus, you will write if, okay, if f of a naught is greater than 0, initial approximation is greater than 0. If it is negative, then you should write here negative, not positive. Okay, so if an is positive, surely bn will be negative, but if an is negative, bn will be positive, surely opposite sense, correct now? Similar case for an, this is for an concept, this is for bn. Okay, the second line. So write an plus or an minus accordingly. Okay, according to f of a naught greater than 0 or f of a naught less than 0. So this is the first case. Second case, bn, just reverse, just check it. Okay, okay. So bn minus or bn plus according to f of v naught less than 0 or f of a naught, sorry, v naught greater than 0. We just see the sign or the restriction. Fine. Now step 4 I have not written, now I will write step 4. Okay, step 4 is the main iteration once again, and then step 5 to continue. Okay, to continue to obtain the our desired result. Okay, now in the, what is that one, in the k plus 1th, okay, iteration, write, okay, x k plus 1 in the column, okay, the column of an plus, okay, of an plus, this is the problem, n plus, okay, n plus if f of x k plus 1 is greater than 0 and keep b k fixed in the column. So same case, opposite case will be there. Okay, now in the column of b minus. Okay, the column of b minus, bn minus. So now you just see we are replacing an plus. What will be the situation if it is reverse? Okay, now otherwise write, okay, x k plus 1 in the column of bn negative if f of xk plus 1. If anybody following me, he or she can answer. This is greater than 0 or less than 0?
Less than 0, sir.
Fine. You are following. Very good. And keep. Okay, but I should not answer again. Okay, now just this time now only. If keep ak fixed. Sorry. AK fixed, okay, in the column of an negative. Am I correct? The last line. Same fellow, roll number 42? No, na? Oh, okay. So an plus. Okay, good. N plus. So this is the step 4. Now this 1, 2, 3, 4, this will continue. Okay, na? So continue this up to step 4. That means this step already 1, 2, 3 already you have evaluated. So step 4 is the computational iterative process. Okay, na? So continue the step 4. Okay. So that is now you should have some stopping criteria. Okay, na? So step 5. Okay. So what is the step 5? Now continue the, just I will not continue the step 4 till the termination criteria. Termination criteria. They are satisfied. Okay. So can you answer what is the stopping criteria? X in which column it should satisfy? Means for which column? That is, you have 1, 2, 3, 4, 5, 6, 7, 8. So 8 columns in each row. Correct? So which one we should check? That is for till the termination criteria satisfied. Okay, na? So for that we have to check an or bn or f of an or f of bn or hn or hn plus 1 or the last one.
Xn plus 1, sir.
Yeah, we have to check this column. Okay, na? This one. Oh, sorry. We have to check this one to. We have to check this column. Okay, for this one, that criteria, stopping criteria is satisfying or not. So that is till the termination. Okay, till the termination criteria satisfied. Okay, for the given or for the just wait, x k plus 1. Okay, or we can write here it is x n plus 1 also. Okay, okay, x n plus 1. Okay, 1 gives the same result. Okay, same result into same results. Okay, in true successive iteration. Okay, so then only you can stop. So now, so what is that stopping criteria? Here it is xn plus 1. So let us consider n equals to 3. N equals to 3. The answer is okay. N x3 is say okay 3 plus 1. It should be 4. Okay, n equals to 3 mean okay. And x4 is 0.213. Okay, and n equals to 4. It is x5 is 0.2111. If your stopping criteria is correct up to 2 decimal place, then you can stop here. That means at n equals to 4. Correct? Why? Now two decimal places, okay, it gives the answer x4 and x5 gives the same result 0.21, 0.21. It is similar to the bisection method. Okay, now here only you have to check. So that's all the computational method. Now we will consider one problem, and you should have a calculator. Okay, now otherwise you can't complete your problem. Okay, now. So now one example. Okay, find a positive root. It's a find, if you can find negative also. Okay, find a positive root, okay, of the equation x cube minus 3x, okay, plus 1.06 equals to 0 by Irregular Falsi method. Okay, and what is the stopping criteria? Okay, so let us consider two decimal places. Okay, two decimal places. So let us see the two decimal places. Let us consider two only, or since it is faster convergence. Okay, I think 2, 3, 4 steps you can find the solution. Okay, so now what is the process, how to write the solution? Okay, so that you can get full marks also in exam. Let f of x equals to x cube minus 3x plus 1.06. Now f of 0 equals to 1.06 06 greater than 0. Okay, and f of 1 is 1 minus 3 plus 1.06 equals to, it is 0.94. Okay, it is greater than 0. Therefore, fine. Therefore, at least
The minus 0.9%.
minus.
Minus 0.9%.
So fine. So
8.
yeah. So less than 0, minus. Okay. Therefore, at least one root. Okay. Or puts positive root. Okay. One positive root. Okay. Root, say alpha. Okay, of f of x okay, lies in 0 comma close interval, should not write 0 comma 1. Fine. Okay, now therefore what is a naught, what is b naught? 1. So this is f of a naught, this one is f of b naught. So I will write that table in the next slide only. Okay now. So the computational table, write down here. Okay, the computational table. So you have to write computational table. Okay now, computational table of this, or computational table of the scheme. Okay, write down an bn f of an. I have till now I have not written negative or positive. We will check and then we will write. Okay now, then f of bn. Okay, h of n xn plus 1, that is xn plus hn. I will write f of xn plus 1. So many drop are there. Okay na, that's why every time one on extra drop. Okay, before we start this scheme, just for checking, okay na? What is HN here? Those are following or writing, they can answer easily, I think so. What is HN? I have not written anywhere it is. What is your roll number, beta? 42. Just wait, I will check from any other fellow, okay? Anybody else? HN.
Yes, sir.
Yeah, what is your roll number?
29, sir.
Oh, good. Tell me, HN. So,
Mod of
here
f
you have
of
to
an.
find, what is that? F of
An into
An into, that is modulus,
B,
okay?
yes, sir. Modulus
Bn
of
minus An, fine, divided by
mod of f of an plus modulus of f of bn.
fine, good. So that will be the Hn. So you just see why I have written this one. When you are at this position, that means when you are finding Hn, at that time you have all the informations. Yes or no? You need f of An here. You need f of Bn, okay, here. You need An here. You need, sorry, Bn, you need An. So all the entries are there before this game. So that's why Hn is there. Fine. So I will erase full this part. So very good. You have answered this question. What is Hn? Okay, very good. And yeah, fine. So now n equals to 0. So now you can answer what is An and what is Bn. I have to go to the previous slides, but since you are following me, so I no need to go back. Correct? You can answer now. Anyone?
An is positive, bn is negative, sir.
Okay. An is, so you have to write here. You should write. Now I am writing. Okay, na? Oh, sorry, not 0. Fine. This one you have to mention. Otherwise, you will make mistakes in between steps. So the iteration, sorry, in the middle of the iteration, so maybe in third iteration, fourth iteration, or the nature, when nature is changing, that time you will be in trouble. Okay, now. So An, it is positive. What is the value of this An? Go back earlier slide and you can answer. What is the answer?
1.06, sir.
0. No. An.
An 0, sir.
0. Now An is, you can see the positive, correct now? And Bn is negative. Already I have written here positive and negative, An and Bn. Fine. So that is the actually, it will give you that true part, will give you the sign of that. Okay. So f of An, what is the answer?
1.06, sir.
0.06. Okay, 1.06. Fine. What is the f of Bn? Minus
0.94, sir.
94. Now tell me what will be the Hn. Just wait, one phone call is there, landline. Just 1 minute. Hello. No, sorry. नहीं कुछ नहीं, कोई ऐसा नहीं था, कोई चेंज करने के लिए कुछ भी नहीं। हाँ मिल गया। हाँ ठीक है। Hello. So what will be the Hn? That is very vital. Hn. Now, anyone? How you are getting that one? That is my question. Sorry. Hn is fine. What is the answer? Hn? 0.52. This one. Now Xn plus 1 is Xn plus Hn. You can answer, I know. You can answer it. That's why xn, what is now n equals to 0, correct? N equals to 1, so x0, correct? So what will be the x0 actually for that case? X0 is A0 or B0? And no, that is not like that actually. So if in this case, you consider this one, fine, this positive one. So 0 plus 0.52, okay. If you say your root lies between what, 0 and 1, fine. So if you consider Bn, then your Axn plus 1 will be 0 plus 0.52. I will explain both. And 1 plus 0.52. So if you consider the root lies between this one, then we are improving this 0. If you add this one, since H is positive, correct? 0.52. Okay, fine. So if you add with 1, then the root actually that is the new solution 1.52. It is actually outside of the interval, correct? 0, 1. Yes or no? Do you understand this one? 0 plus 0.52. That is the one. That is the interval 0, 1 we have considered. I will go back in just 1 minute. Okay. What we have written? That one positive root, say alpha of f of x, lies in 0, 1. Fine. So what is the an? 0, bn is 1. Now that means somewhere x0 is there. If you consider any n inside between inside that one, x0 is there. So now x0 is, say, if it is 0, or x0 is, say, it is 1, if it is 1. So if you consider now x1, that is x0 plus h, and x1 is x0 plus h. If it is 0, it's fine, 0 plus h. If it is 1, okay, 1 plus h. You just see the next one, it will increase. So what will be the answer? This, yeah, this should not be the answer. Okay, now. So just 0 plus 0.52. I will erase both and I will write. Okay. So 0 plus 0.52. So now f of 0.52. So that means f of 0.52. What is the answer? 0.5. 0.53. No, but somebody told h is 0.52 or what?
0.53, sir.
Oh, sorry. Okay, 53. Fine. So f of 0.53. What is the answer? F of 0.53. Just put in that equation, you will get the answer. Minus 0.3811. It is less than, correct? It is less than, fine. So n equals to 1, we should not replace this one since it is positive, correct? So we should replace the negative one only since this one is negative, fine. So now I will write this one is 0.53. I think if you have any doubt, you can ask right now. Okay, I will answer that one. So now xn is just take 0.53. Fine. So 0.53. 0.53. So this is the 0.53 in this case. In that case, okay, the f of xn plus 1 is negative. And according to our previous, here, just see which one should be replaced. Okay, if it is positive, then positive one should be replaced. If it is negative, then negative one should be replaced. Just see the step 4. Okay, so that is the case. So here it is. This one is for the negative, but here it is negative again came, so it should be replaced by the negative. Okay, so f of a negative 1, so 1 point. Now what is f of x on an? What is f of an? It is remaining same, correct. Now what is the f of 0.53?
minus 0.381, sir.
Yeah, very good, very good. No need to check, correct. No need to find, already there, minus 0.3811. Fine. Now Hn, this one you have to find. What is the value of Hn? The same formula. Now these are the new entries, not, you forgot about this one now. This is your new entries. This one, this one, this one, and this one. So what will be the Hn? .3898. So if you add that one, okay, so it will be like, what will be the answer? Okay, the earlier one is 0.53, correct? Earlier one 0.53, you just see here, okay, 0.53. So now you are adding this one with this 0.53. So what is the answer? No, not same, not this one. Here, xn, earlier the answer is xa, this is x naught, correct? Now, x1 you can say, correct? Now what is x2?
0.9198, sir.
Yeah, 0.9. Yeah, but a power cut. So actually, internet also can have joined again through mobile data. Okay. Am I audible?
Yes, sir.
Fine. So what is x2? 0 point, that 0.53 plus 0.03898. What is that? What is the answer? 591. This one. Or 98, na? 98, correct. That has already, it is there only. Yeah, okay, just wait. Yeah, not presenting. Today, actually from morning onwards, almost 4 hours means power cut. Right now also there is no power, only from laptop backup. I'm taking just 1 minute. I have shared now. I have shared the screen. Is it okay? Visible now? Yeah. So x2 is now 0. No need to write x2. Okay, now you just write the data only. Okay, now. So 0.9198. Correct? Yeah. Or yeah. Fine. So now for that x2, it is negative or positive? Positive, negative. Okay, again negative. Fine. So it is again negative. Minus 0. Okay, something I am not writing. So negative. Correct. So when n equals to 2, okay, it is 0. F of 1.06. Now f of Vn is minus 0. What you to answer better here? You have to find every time, since you are there, this is the same. 9212. Fine. Now Hn. Three 3585. Is it negative or positive? Positive. Okay. So now 3.85. I see. X1 0, X2 I've done some mistake, correct? Huh? It is 38. What is the exact solution? You just put in your it should not be add. I have added with 0. What is the answer? What is the original solution? 3 point something, correct? 0.3.
0.31.
0.31. 0.31. So actually we have done a mistake. So it should be not 0 plus. It is with, it should not add with this one. Okay, it should add with this one only. Okay, so 0.53, then 0. It should be 0.31. Okay, 0.38. Also that one also it will be negative only. Okay, 0.3898. Now here it is x3 again. It will be 3.3585. Okay, but you add with this one only, first case. Okay, improving that one only. So 0 plus a 0.53, again 0 plus this one 0.5, this one plus 0 plus 389, and now 0.3585. Okay, so now at 0. F of 0.3585, what is the answer? 3585. What is the answer? .035 positive. Positive. Okay. So positive means then you have to replace this one, positive one. Okay. So in 3, okay, it should be replaced by 0 point. Okay. Oh, you have considered this one also, na? 9198, correct? Okay. So all will change. This one also will change. Okay, here itself I will change, no problem. Let us see, I will change. Okay. Just Bn will change, correct? Okay. Then Bn will. Here we'll get something different, correct now? Yeah. Okay. Just wait then. So this iteration itself, a mistake is there. Okay. So ultimately this is not correct? So fine. Okay. Here itself. Fine. So if you have the data, you can just tell me what is the answer. It is minus 0.38, correct now? So it is 0.0, then 0.53, it is 1.06 minus 0.3811, correct? So Hn, what is the Hn for the first case, first iteration here?
0.389, sir.
0.389, fine. So what will be the x0 plus h, correct now? So it is 0.389, fine. What is this one, negative or positive? 0.389. F of 0.389. Minus 0.481, correct? So iteration 2, 0, here it is 0, 0.481. So 0.389, okay, it is it should be 1.06. This is minus 0.0481. Now Hn will be the Hn. So Hn is, tell me the Hn. .3721. Okay. So this one also 0.3721, correct now? 0.3721, 0 plus that one. Now it is negative or positive? Now it is fine. Okay. So f of 0. 47, correct. Okay, so iteration third, so remaining 0.3721. okay, f of this one 1.06 minus 0.0047. Now hn. Zero 72754. So 0 plus again that one same. Okay, now so it will be 0.2754. Okay, so the answer is ultimately, now here it is negative or positive again. Positive or negative? Okay, 0.2546. okay, so now 4, now only power came. Okay, 0 b, no, sorry, now it will be not 0. What is the answer? 0.2754, correct. 0.3721, negative has not changed. Okay, now this one is f of n will change 0.2546. Is it 0.2546 now? The last one. Okay, now you tell me the f of bn. F of bn, four 7 remaining same, correct. Now hn. hn 0.0949. What is that one then? 0.2754 plus 0.0949.
Sir,
Yeah,
sir, in third iteration, I got 0.3702, sir.
3702. Here.
HN, sir. In third iteration itself, I got 0.3702.
3702.
And it is the solution, sir.
0.3702. Yeah, then it is 2754 or 3702. It is 3702. Is it? 3702 means that is the answer. Okay, then I will change it. So this here, so no need to go for fourth iteration, correct? Why? I will just tell you. 0.3702 02. Fine.
Yes,
So
sir.
here also that is not the correct one, since this is not the correct one. So this one. So xn also 0.3702. Okay. Fine. Since two successive iteration, okay, giving you the same result. Okay. The stopping criteria. Okay. This is the stopping criteria. You can stop here. Why? Now two iteration 3 and iteration 4, having two decimal places, same result. Okay, 3.7.37. Therefore, so this is the problem actually. You should have calculator, and you have to do you have to check each step that you are finding correctly or not. Okay, so the recorded solution or recorded root is x equals to 0.37. Okay, approximate. Just just check it. If you put 0.37, what is the answer? That f of x?
Yes, sir. Almost 0, sir.
No, almost 0 means 0 point something, no? What is that? Just put 0.3702. My answer question is f of 0.3702. What is the answer?
0, sir.
0. Oh, 0.0001. Yeah, that is fine. So just take earlier that 0.25. Sorry, this is wrong. Correct now. So earlier minus 0.0047, and now another 0. Correct now, 0.000001. So that means actually you will get two decimal places answer same. Third decimal only you will be different. So that's why 2 and 0. Okay. So 0.001, maybe plus or minus, whatever maybe. Okay now. So therefore, the recorded root is this one, 0.37. Fine. So I will not give you today any homework. I will consider one more problem for computational only on that one, Regula Falsi, in the next class. Then I will give you